Hello everyone, I am Satya K, Assistant Professor, Electrical and Electronics Engineering, NMIT Bangalore. I am here for a small demo or to provide a simulation using PLECS software. So PLECS, which stands for Piecewise Linear Electrical Circuit Simulation. So this is a specialized software developed by PLEXIM just for modeling and simulation of power electronic systems. Okay, let's open the PLECS. This is the software. As in when we open, we get to see the library browser. To open a circuit window, circuit editor window, so what we are supposed to do, go to File and then New Model. And here is what we have, circuit editor window. So let's maximize a bit. Okay, so now we are simulating the buck converter, okay, using the PLEX software. So here we have annotation system, assertions, control, electrical, thermal, and then magnetic, mechanical, okay, PLEX RT box, STM32 target, TIC2000 target. Now, let's take out all the components of buck converter. So we need to go to electrical. So here in the sources, we can obtain voltage DC source, drag and drop it here. And then we require passive components like resistor, inductor, and then capacitor for buck converter. And then we also need power semiconductor devices like diode and then MOSFET, which is used as switch. Okay. And then we require the meter, which is available in control, not in control, sorry, it is in, okay, in the system. Let's take the scope to find the output. And then we require in control and sources, we require pulse generator in order to provide pulses to the MOSFET. And then we require meter in that voltmeter. Let's take it. Okay. So I suppose we have taken all the components which are required for buck converter. So DC source, and then we have MOSFET here. Let's connect it. Then pulse generator required to provide the pulses to MOSFET. And then we have diode. And then we have inductor here. Let's rotate it. And then we have capacitor. Then connected resistor. And voltmeter is connected in parallel to your resistor. And we are measuring the voltage across your resistor. Okay, so unlike our general purpose tools, this PLEX focuses on high frequency switching behavior, loss calculation, and efficiency analysis, which are critical in power electronics design. Okay, and this also, as you all see, as you could see, we have ready to use models like power semiconductor devices, passive components, and control blocks. So this helps us in making the converter modeling very simple and efficient. Okay. Now, diode voltage drop is 0.7. Let's fix it. And then, as per this design parameter, we are going to design our buck converter. Okay, so our input voltage is 12 volts. And then output voltage, we should obtain 5 volts. And then switching frequency is 25 kilohertz. Then we have duty cycle 0.4. Inductor is 100 micro. And then capacitor is 1000 micro. And then resistance is of 10 ohms. Okay. So now let us run it. Go to simulation and then start. Let us see the output. So we are able to obtain the 5 volts output from the output of a buck converter. Okay. Okay, so this is our buck converter output. From this, I think you would have understood how to simulate the buck converter using PLECS software in open loop. Okay, thank you all.